Hey everybody, this is Larry, this is Miko Q3 of the weekly contest 48. Count subarrays with cost less than or equal to K. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this one. Honestly, I thought we either this or some variation on this, but maybe not. Maybe they all feel like variations, maybe variations is correct. The key thing to know about this problem for me anyway, the key observation, the first one obviously is 10 to the fifth, so you can't do n squared, fine. Okay, but the other key observation is taking a look at this function, right? And what happens? Well, we're trying to find less than or equal to k, right? Fine. But that means that this formula means that, particularly this part is more obvious, right? Which means that the more items you have, the bigger the cost will be, right? That's one. And then this part as well, actually. The more numbers that you have, the bigger it will be. Of course, it doesn't have to be strictly bigger. It could be equal to, but you get the idea, right? Because as you add more numbers, this part will only get bigger, and also this part. Which also means that conversely, if you shrink the window, if you call it, then it will only get smaller. So then now it creates an invariant where all you have to do is just keep the window less than k, because there's this idea of sliding window. I know that I talk about contributions from videos to video, but for me it almost feels like a frontier thing, right? Which is the same as sliding window, but with a different visualization, right? Implementation, they all may look the same, but different visualization and different ideas may allow you to get to the answer in a way that is more straightforward. But the idea here is that, okay, you have an array, right? So then you add a number, and that means that you shrink on the left side, or possibly if it goes bigger, right? Because that's the frontier getting, and the reason why I say frontier is because, okay, it shrinks, but that means that the next number cannot go back up, right? It's a frontier because it just keeps on shrinking to the right to follow. That's also how you get the sliding window logic, but sometimes that's how I think about it. There's no differentiation per se. There's no, it's not definition. It's not a definition-y thing. You don't have to be pedantic, but it's just about having that visualization in your head so that you're able to kind of do these incremental things, right? Anyway, and that's basically the idea. I'm not gonna lie, there is a more optimal version of this, but we'll go over the sliding window frontier thing first, and count is the result. Left is left side of the window, so when we come to right, at this point we have left and right inclusive after adding the num sub right? And then now here, what does this check do, right? This check means that at the end of this check, and this is just an invariant, the score will be less than k now, right? And then that's why now you add the size of the subarray, which is this inclusive, right? And that's basically the idea. And this works regardless of what add and remove is, right? Because of the property that I was talking about and frontier and stuff. But for this particular problem, the check would be, you want to get the max, you want to get the min, you want to get the length. The length is relatively easy, so you have to worry about the max and the min in a sliding window kind of way. And there are two ways to do it. One is by using a sorted list, or like a binary search or balanced binary search tree data structure interface. So in other languages, could be, I don't know, even there's a set in C++, but that's not quite right. A multi-set, that's the word I was looking for. Multi-set in C++, for example, and so forth, right? Because you need multiple non-unique elements, right? But it also turns out that because we are doing this like sliding window-y thing, and you always pop from one end and you always push from another, you can implement this with a mono queue, which is a name that I hate, by the way, but basically, a monotonically min queue, if you want to call it that, and that will basically, this part will look the same. If you have the data structure ready, this part will actually also look the same. It's just that you can't declare them. But if you don't, which I have it somewhere, but this is faster for me to write, and I just use the sorted list. So if you want to solve this, these add operations are log n, remove is also log n due to the sorted list. So that makes this n log n, right? We add, every element gets add once, and every element gets removed at most once, so it's n log n, amortized for the removal. And check is just O of 1 because it's max min. You could even cache this if you really want, but yeah, if you do use the mono queue, then this becomes O of 1, or this becomes O of 1, and this becomes O of 1, which makes these two O of 1, which makes this O of n, which, I say try upsolving it that way. I definitely have videos on it. I'm a little bit, lazy, tired today, so I'm not going to do that. But yeah, that'll be your homework at home, or your homework at wherever you want to do. Homework at home or homework at work. Wow, homework does have both things, doesn't it? Huh. Man, okay. Shower thought moment over there. Anyway, thanks for watching. That's all I got for this one, and you can watch me solve it live in the contest next. I thought it was something more silly. That was silly enough, but I meant like less silly, I suppose. Okay, let's keep going. Causes max times, so like the rectangle thing. I feel like oh no, it's max times min. So it is literally the area you draw it under the thing, but n is 10 to the 5th, so it's actually a big number. And it's subarray. How do I write this? Less than or equal to k? Man, there's so many moving parts. I gotta think how to do it. Okay, so we do 1, 3. What is the population? 3. So this side can get bigger as you add more number. This side will get bigger if you add more number. So that means that it's almost like a binary search to the left, maybe. And then you get a subarray binary search. So n log square n. Is that fast enough? N log square n. Is that fast enough? No, binary search is because you're lazy. It is straightforward if you yeah, because the number of array is just so then you just go as far as you can, right? I guess that's a pretty straightforward sliding window problem. Something like that, right? And then count is equal to right minus left, or maybe right minus left plus 1. So that's the structure, right? So then add, we probably want a mono queue really, but do I need it? No, we don't. Then fine, let's use sorted list. I mean, this may bite me, but that's fine. It's easier to type. It's not even easier. I think it's actually longer. Actually, I don't know if that's true, but it's just less thinking. No, that's it. I forgot I was thinking of the other one. That's the number of elements, right? So if you have one element, So it could be 0, right? Am I confusing? Oh, because this part would be 0. So one element is always good. Okay, I see. That's what I was looking for. I'm a little bit slow, but whoops. That's not right. This might be a 2, 6. It's just. Oh, maybe I'm not counting 1. Oh, well, okay. So then, I actually should have known this one, but or I should have tested this one first. Because that's just straightforward test. But I was like, I thought this would be right, but I thought because one of the bounds would be outside, but I was wrong clearly. Not that bad. I was just lazy. That's a mono queue thing. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.